Good day everyone. So welcome back to another stream tutorial. So today we're going to look into effective delta management, or these are some basic ways of handling incremental delta when you're loading transactional data from SSIS. I've got two pre-set up and we're going to build a third one. The two preset, the first one is a slow way, traditionalist sort of way of staging data and then doing an insert. The second one is using a traditional lookup. And the third one that we'll build live in demo land will be a way of merging delta to, well, really efficient way of pulling massive sources of data together, because obviously we'll walk through some pros and cons as we're doing things. Right. So all the source code, first of all, will be available in the link in the stream. So I'll include the SSIS project. I'll include some basic scripts to create tables, and that's pretty much it. It will be quite self-explanatory. So just to start off, we have a data set, a transactional data set that we're going to be labbing. It's completely fictitious. It is just a way of creating consistent test data with some fake identifiers that will help us do this stuff. Let's have a quick look at that test data set. So it is here. If we run this portion, stop that, don't need to return all million rows. We have a transaction ID, which is a bit of a funny non-sequential ID. We have a transaction date and we have a weekday. I will be building on these, as these tutorials go on, when we start looking at how to handle dimensionality and so on and so forth. Right. I just started creating something simple because when you're loading delta, you're obviously going to go, well, I don't want to include the same thing twice. I want to make sure my stuff's incremental and that sort of thing. So let's start off. If we go and look back at what I've got running, so I have my sample delta sample screen. Just hold on a second. Right, sorry about that. Anyway, so simple database setup. I have a that's from my previous tutorial. So I've got two tables. I have a stage table and I have a live table. So the live table is currently populated with lots of data, a couple of million rows of data. Not sure how large this table has become. There's only a million rows. Awesome. Which means that I haven't inserted a single new record in my runs. Right. Let's go ahead and truncate this table for the demo. So we go truncate. If we go, table is now empty, and there we go. Then we have a stage table that currently that we're going to load data into, and that's just one big heap. Yeah, off we go. Lots of data here. Let's go ahead and truncate this one too, just so that we. Alright, so I'm missing an N. Just so that we get rid of the data. Let's just prove that the table is empty. Right, so we have nothing in our stage table, and that's probably, well, pretty much it. So the idea is that the first slow way is we're going to insert data into our stage table, and then we're going to do an insert with a where clause that sort of doesn't insert duplicate data. And the idea is that this transaction ID column is unique, right? Which it is, because that's how I set up the sample set. Right, so if we go ahead and let's just clean this up. Don't need to see all this stuff. And let's go and step through the ETL. We start with the slow one. So the slow one is really simple. First step is a truncate, which we've already done. Boom. Second one is we insert the data into our stage table. Here we go. Here comes a million rows. Boom. And then after that we have this execute SQL task to insert data into live. I just want to show what the table looks like. Right, there we go. So in our stage table, we've got our stage data, right? And then in our live table, we have nothing. Okay, and then we have this piece of, well, this insert statement. Let me grab it out of SQL. Oh, SIS. We got this insert into, which is really not efficient at all. Let's just run the query here. Let's paste that in, which basically goes and says insert into our live table, select transaction, transaction date, and weekday from our stage table where transaction ID not in, off you go, right? We can run this, and we should have data. There you go. Okay, so when looking at this, you know, one thinks, okay, well, this is not the most efficient way of doing things, and especially not in SIS. In terms of SQL, it might be quite efficient, even though the in statement is probably worse. We should probably have some join, and we do an insert into a filtered view or something like that, and it might be more efficient. We also might want to start putting a whole bunch of indexes on our stage table, and we might want to break this up into batches so we don't do massive page locks, and there's ways of making this efficient, right, or more efficient. I don't like doing it that way. I like staging data, that's not a bad idea, but I don't like to try to insert a whole bunch of data unnecessarily. So the next more efficient way of doing this, let's just go and truncate the stage table. Right, so now our stage table is empty, and we still have data in our live table. I just want to get the last date, so I know pretty much. I mean, it's 1 million minutes of data that I've inserted from 1st of January midnight 2000. So I just want to get. I've clustered. Sorry, by the way, I do have a clustered index, and I just want to see what my last date is. So that's November 25th of November 2001. That's when my millionth transaction came in. So if we want to add 500,000, we just go and change our date range and add another 6 months, and then we have 500,000 new records and 500,000 old records. So if we go back to our SIS package, so I've broken up the source select. So this guy is is wrong. He should be a command variable from that guy. So I feed in a variable so I can choose where I start from, right? And that should be true for this guy too. I just want to check him quickly. Okay, he's not. I did the work, but I didn't make it official. Right, there we go. Done. So that they're variable driven. So in this project, you got this start or from date thing. So if we go back and we say we want to start from 2001 there. I think that's yeah, okay. We can start from 2001. Let's do it a little bit later. So we do June 2001. Right? That means that we're going to get a big overlap in our in our ETL. So if we run this guy again, he's now going to go and we insert into a stage table, right? And then after that, we're going to be going and insert the data from the stage into the live with this nastiness here, right? And that's not really great, but let's take it as that. Let's try it and let's see what happens. So if we run this again, so if we look at the last execution, right. Tell you what, maybe we should start from, no, we're not. We'll do this live anyway. Right, so if we go and we look at this thing, so if we run this whole container, right, and we run it, it inserts into the stage table, and then from the stage table it's going to go and insert data, and sometime today will be done, hopefully now, right. So not too painful, but we only have 1 million rows and 500,000 rows we just added. So if we go and we look here, it took us 14 seconds to complete this action. Okay, is like 14 seconds, not too bad. Okay, well that's great. Let's stop this one. Let's go and inspect what we have done this side. So this side, you'll note there's no temp table, there's no truncate action. There is no execute insert into live, so I bypass the truncate the stage table. Best practice: use stage data first. This is just for demo, right? And then if we go and we look here, so we got the same source data set, right? Really nasty 3 columns. We have a lookup transform where we go and look. So we pull our transaction IDs from our live table, and we then try to match our incoming transaction ID to our stored transaction IDs, and then when we get matches, or when we get no matches, we redirect them to no match output, right? Makes sense? And then we take the no match and we insert directly into the live table, right? And straightforward mapping. Now, this is not the most efficient way of doing things, because we could tweak this even further. Again, like I said, I prefer to have a stage action where even though I have these live transactions, right, and I trust that my logic is sound, I'm still going to insert or insert this data in a production environment. I would build this to be inserted into a staging table first anyway. And that way I would guarantee that when I can then control the insert as well. It just means that my insert is smaller. Okay, so if we go and run this thing, so remember that was 14 seconds. Let's go and see what our max data is and set it. Set it to something equivalent. So now we've got, yeah, okay, December. So if we flip this 1 year forward, or 6 months forward, I think it is, we did last time. So we go into our variables and we go Okay, let's set it to 2002. Wait. Yeah, 2002 and yeah, beginning of 2002, right? So we're going to have a 12 months with additional data, right? And it's representative and similar to what we did last time. Then we go and we run this, the lookup one. So remember, 14 seconds was the previous one, and here comes the one with the lookup. And it's running, and you can see it coming in, but it's not pumping data until we hit there, and we start to pump data. Right, happiness is 300,000 rows were inserted out of 1,000,000. Cool. Stop this, look at the execution result, and that took a whole of 7 seconds. Wow. So 50% more efficiency with this way. Okay, and then obviously there are some repercussions. Now, I don't want to get into too much detail, but data flow tasks or SSIS works with input and output buffers, and it caches data in a certain way and keeps things in memory, and it's got row buffers, so it limits the amount of transactional rows it can have per buffer, and then it has to flush it, etc., etc., etc. Now, the reason I'm quite happy with this query, even though we have, this is a single big int column, and if we run the maths and oops, did I see? And we say a big int is 8 bytes, right? And if we go and say times 1 million, 1 million rows, right? We have 8 million bytes. Then we go times 1024 bytes, so we get, oh, sorry, my bad. Let's start again. So that's 8 million bytes, and we divide that by 1024, we get kilobytes. And then we divide it again by 1024, and we get megabytes. So we know that each 1 million rows of data is 7 megabytes. Now, in terms of being optimal, right now we're safe because our lookup connection buffer is 10 megabytes, so we're good. We know that if we want to load this, so there's a million rows of data. If we want to load 10 million rows of data, this is now going to be 70 megabytes of data. And our limit on our buffer is 100 megabytes. Right, so that we're starting to get to not dangerous territory. There are other ways of caching the lookup transforms. So you can have a caching database. You can do a whole bunch of stuff, right, to make it even more efficient. But generally, a lookup transform is good if you're running. You're not pulling too many results, because once you start having to flush and reload buffers to do your lookups, you're going to now start doing more and more computation, and it's going to be more and more heavy, and you have to reload data for each set of data that comes through. Right. So lookups are great, but they can be dangerous, especially for efficiency. For this kind of job, it's one column. You're just doing it to filter. Not too bad, and we know the data set is quite small. If it grows, well, that's a different story. Right. So if we I'm just going to hit OK here, and we're going to load. We're going to change the query to load 10 million rows of data. Right. So we go to our variable, and we go into here, and there's a where statement. So we just add a 0. So 10 million rows of data. Okay. And we're going to run this guy again, just as a benchmark, because this is our most efficient, least efficient, most efficient. We're going to build a new one that's even more efficient. So if we execute this container and run him, and you're going to see in the data flow that, we're going to do 1 million rows and nothing's going to change, but then 9 million rows are going to come through. And you can see that it is struggling a little bit here, because the source table have become a little bit larger. And I have a feeling we might be over our 10 meg limit as well. It's still pacing quite fast, and it's going quite good. Don't have an issue with, so okay, it's starting to struggle a little bit in throughput, buffer sizes. We could optimize this, but that's another tutorial for another time. Right, just wait for this guy to finish. And he will be done now. Right, great. So again, we see, first million rows were ignored, and then we add another 9 million rows on top in this table. Cool. Right, if we go and we look at the execution time of this last one, okay, so it was 1 minute and 20 seconds. Okay, let's just do a quick snip of that so we have it stored. Yeah, just think that's our evidence. Put it off screen. And now we're going to make this more efficient. Okay, so the other way we can or another way we can build these without using a lookup is if we use joins. Now, the issue with joins is that our data needs to be sorted, which in this case it's not ideal because we have a non-sequential sort of business key, primary key that we're using, or business key, transaction ID, right? But we're gonna just make a copy of that and create a copy, right? And this is, let's just change that from lookup to doing merge lookup. Okay, so our merge lookup has a little bit more complex data flow. It looks more like this guy. So if we just paste that truncate statement in, because we're going to use our staging table for this one, and we're going to also use the same funny one here. But for this one, we want to ensure that we bypass everything in our source that is not required. So we're going to go into our parameters. We're going to just copy out this variable, and we're going to do a new variable, and we're going to say merge transactional SQL, right? It's a string, and we paste this one in. We just need to put an order by clause on. Right, so we're just going to go select star from open bracket close bracket, alias that, where order by, and this is going to be nasty, order by transaction ID. Now, transaction ID is a randomized begin, so this is not inefficient, but we need the code sorted. Okay, so that's our first, or that's our new one. We in the and we're in this one. So we go in here and we go some source data, and we go, it's not you, it is you. Okay. Then we need to get rid of the lookup because we don't care about the lookup. We also don't want the loud table in here. What we do want is what is, well, we need here a merge join. Where's a merge? There's a merge join. Right, great. We need to prep some stuff, so we need to open up the advanced editor. We need to go to our is sorted on the source. Say it is sorted. We also need to tell this guy that sort key position is 1. That's our transaction ID. So that's now what we've ordered by. And then we pull this guy into there. And he is our left input. Okay. Then what we do is we go and create a new source. Where are you? There, only DB source. We'll call this one src transaction live. Right, so there's our live table, and we want this to be a SQL command. We build a query. Go here, it's our live table, close, transaction ID, and we go order by transaction ID. Right, the reason why we're doing this sorting is because we need, oh wait, hold on, sorry, I don't need all this stuff, I just need the transaction ID. Sorry, almost made a blooper there. So the reason we do this order by is so we get this in a sequence. Hopefully, in your real world scenario, it won't be this random. Okay, but this is still better. Then we drop it in there. We go and tell this guy that he is sorted, and we go into our output columns. And we tell this guy that it's sort position 1. Okay, we go in here and we say, yep, that's all good. Like to see those, and that's it. Right, that's all I care about. So what's going to happen, because this is an inner join on the sort keys transaction ID, we will bring through the data. Actually, sorry, I am wrong. I want to show that guy too. Sorry, my bad, almost made a boo-boo. And this we go and we say this is, what should we call it, existing key, right? So now what we've done is we're saying if we get a match, we also pull through this guy as well. Okay, data is merged together. Then we're going to use that additional column that we created now in a conditional split. Now, a conditional split is what it sounds like. It splits data in data flows based on conditions. So we're going to go and say if. So we're going to go and say this guy, the condition is null, is null, that guy, comma, I don't know, some number that won't exist, equals -1. So basically we're saying if there is no value, right, and this in this existing key, it is, if there's no value, we set it to -1, and we look for the inspection of it being -1. Ooh. No. I gotta look up this. I gotta look up how the cases work because I cannot remember. let's quickly Google together. Right, so Google is our friend. I haven't done this for a while. Conditional splits expression. Right, so there you go. Question mark, colon, and then right. So I'm looking for the example because I'm silly to understand. There we go. So if variable okay, right, true, false, right? So there's our statement or our expression, and then question if it is true or false. Okay, right. So there we go. Let's go back. So is null question mark. No, but that can't be true. That doesn't seem to be valid either. Okay. Equals. Maybe I need to string bracket this thing. No, I mustn't. Okay, interesting. We'll I'll get it right. SSIS conditional split. Examples. Right. Let's have a look at the conditions. Right. Yeah, no. Yeah, this is what I'm doing. So why is the is null? So is it the is null that's breaking then? The is null. Oh right, because it's not is null. Sorry, my bad. It's replace null. Right. Thank you very much. Great. Okay. So this is new. We're not going to do the other one because the other one is existing. We have this default output name, right? So if it's null, then it's new, else existing. This should work. I'm a little bit worried about using -1, but it should work. Right. So now we have this table that says, well, if it is existing, then drop it. We don't want to care about it. If it's not existing, we want to obviously insert it into our staging table for insert. So we go only db destination, and we go and we pull here and we say it's new, so new records, and then dst transaction table, transaction live. Right. We go and say it's data live, map the columns, happinesses, and we're good. Right. So if we run this new one, I just want to run it so you can see what the data flow looks like. So let's just go and execute. And you can see in the data flow that takes a little bit of time to run because we need to start building. We're running an order by clause as well, which means that we should probably put an index on some stuff now, because this does not look efficient. Holy moly, this is going to take forever. Stop. We're going to make it great again. We're going to make the SQL query great again. So if we go and we look at this guy, clustered index scan, nice. But let's have a look at our delta live table and the indexes. Yeah, no, let's just go and say new index non-clustered, and let's just add transaction ID. Non-clustered transaction ID. In assist, this is gonna probably take a little while to run, and I should probably have truncated the table before I ran this. But since this is Streamland, we're expecting for things to be a little bit buggy, but not too bad. Right, great. So now this index is created. Let's have a look at it. A little bit better. If we now execute, it goes really fast. Great. So now order by clause is really, really happy. Let's see what happens now if we run this one. So let's go execute. So let me just hide the stuff so we don't need to look at it. We got some more space. I can find that stuff. Right, we go execute container. There we go. Yeah, not the fastest. And I'm gonna blame that on our source query. Unfortunately, this is not coming from a physical table. I cannot make that more efficient. Holy moly, now we're just gonna have to sit and wait. In fact, we could, you know what, let's just make this a bit smaller. Let's go and give it the original query rather, this big one. We're gonna minimize that. We're gonna make it a bit smaller, this table. Right. Let's go and edit the parameter. We'll take that guy. And we drop, yeah, that's 1 million rows of data. Let's drop him to 100,000, and this is just from a, I know we changed the scope of this, but it's, I'm gonna have to materialize this guy to make him faster. There we go. Execute container. Yes, there we go. Lightning fast. And you can see that we're stepping IDs and getting data through. And there we go. 100,000 rows inserted. So yes, it's not comparable, but yeah, it was. Yeah, not happy with this guy. Yeah, not happy at all, actually. Not happy with the example. Let's materialize some records and then we try to actually, let's not. You're gonna have to trust me in this one. This is a more efficient way of doing it, but it requires this to be sorted nicely and not be a bunch of variable tables that are really inefficient. Bad example. Let's try 1 million rows. See how nasty that guy is. Right, so 1 million rows of data. I'm feeling this is going to be really inefficient. going to take quite some time before it starts. Okay, well, wasn't too bad. Not too bad at all. So, sorry. By the way, that was our 10 million rows with the lookup was 1 minute and 20 seconds. It was 14 seconds for a million rows. So how long did this one take? 18 seconds. I want this guy to run 10 million rows. In fact, he's going to run 10 million rows. We're just going to have to sit and wait until it starts spooling data. Let's try it. $10 million rows. Okay, because I want a comparable result. If it's under 1 minute and 20 seconds, then it's resolved. Tick tock, tick tock. Oh man. I don't want this to become a demo fail. It's starting to look like a demo fail. I don't like it. Demo fail. Don't like demo fails. There we go. Oh, sorry, I wasn't looking at the screen. But looking promising. So remember, 10 million results was 1 minute and 20 seconds. Here's another 10 million results. Completed. Yes, it's done. And that was 1,020,000 seconds. It's only because our inefficient source query. Let's go materialize that one. Just bear with me for a second. I'm going to create a table that is sorted. Just give me a second. I want to grab this guy. Let's go and grab that guy. So I just want to generate a temporary table that we can use. Right, so let's add a bit of data to this thing. So let's put him in. Let's find out which year we're in, because this table is. Sorry, just got to find my. It's in here somewhere. Okay, we'll find it this way. So we go here, select top 1000, order by ID. Sorry, ID. I hate autocomplete on ID. Descending. Let's just find out what this date is. So We're in 2021 now. Way in the future. So I don't know. Let's put ourselves in 2010. 2010 is good date. So 2010. Right, then we go and dump this. So pre-sorted into underscore test transactions. Right. Go run this. Let's just make sure it's 10 million. Yes, it is. Right. I'm going to run this guy. Insert into our demo data. 10 million rows of data. Hopefully we don't run out of drive space. No, we won't. We're good. Obviously, this query will take a little bit of time. We should probably. We need to create we need to create an index on this table, or else the order by clause is going to be, well, not going to be great. Right. Is this the right one? First of all, yes, it is. Okay. So let's go and have a look at this guy. There we go. Okay. Right. Let's go ahead and create an index. I'm going to create that guy on that column. There we go, not too painful. Right, then we go and say order by what was it? Transaction ID. Oh no, I created him on the wrong column. Oh man, that's no good. Man, I created the. Look at that. How inefficient are you? Oh man, let's go delete that index. Let's create another one. There you go. On the correct column. And hopefully this doesn't take too long. Now, remember, we're trying to beat 1 minute and 20 seconds. Okay, so yeah, now it spits out data fast. Great. And you can run this one, take away that. Right. Take away the hard-coded database name. Copy that. Go into our package. Go into our variables. Take this merge thingy, bob. Paste them in like that. Right. So now we've got this nice select. I know it's not test data. Well, it is test data, but it's a little faster. So let's go ahead and execute this guy. 1 minute and 20 seconds is what we're trying to beat. Damn it. Why is it not looking good? Oh, there we go. It is looking good. Come on. 1 minute and 20 seconds. Okay, it is looking promising. Not going to lie. It is looking promising. Again, normally your sort key should be sequential. You know, there we go. Ooh, we're done? Yes, we're done. We're done. How long did it take? What was the runtime? Yay! 42 seconds. Okay, versus 1 minute and 20 seconds in a comparable result. Okay, right, great. So I hope this actually proved that you can scale these sort of lookup and deltas. And yes, lookups are great when you're dealing with smaller data sets, like you're looking up a dimension that has under like 5 million rows of data or 10 million rows of data. But when you start going really big things, like let's say you go to slowly changing fact, all right, and that's nasty. So you need to go and update fact tables. You know what? You're going to have to use merge join with a conditional split to drop things out. You could also have, because then you can say you have an update process for things that you don't have. You can insert into your live, and you can say your existing one. You can then have a delta process on the data to inspect if it has changed as well. So you can cascade this out further and do like, well, if I've seen this record before, is it the same or has it changed? So you can have a hash on a folded hash on whatever your attributes you want to inspect or change for slowly changing or for updates. And if they've changed, insert into a staging table and then do a merge back into an update transaction back into your live table, right? So that's an efficient way of handling massive things, right? Anyway, I hope you learned something. In roughly about 30 minutes after the stream is completed, I will have all the source code up in links below in the description. You guys have a good day, and yeah, best of luck and happy hunting. Don't forget to like and subscribe if you want to see more of this stuff.
I am sushi, no one can get me.